Hi, this is Mrs. Lemke. I'm going to go through the most commonly missed questions on the longer SAT practice that you have done. So I will show, much like with the other video, I will show all of the answers within this, but I'm going to talk about the ones that were missed most commonly. Again, a lot of times I hypothesize that some of these were missed because maybe you haven't had a class yet that talked about them. We had some geometry-based questions that came up a lot, as well as some that were more like almost like a statistics question, which you may or may not have encountered in your classes yet. All right, so this first question, I was a little surprised that we missed this, but I think we might have just been wigged out by the story behind it, because the math is actually not too painful. Okay, so this person is planning an event in a room that has an area of 5,400 square feet. So that's expressing the space that's available. So there's some room, and this space inside of it, this two-dimensional space, is 5,400 square feet. For every person, it's kind of a social distancing question. For every person in the room, every person requires about 8 square feet. So each person has a space that is 8, and the total amount of space is 5,400. And they're wondering how many people could fit into the room under this rule. So you're really taking the total space and chopping it up or dividing it up by 8 square feet sections, 8 square foot sections. So it's just 5,400 divided by 8. And that's 675. Okay, so I personally think that that was just wigging out about the question. I was a little surprised that came up as commonly missed. This next one I think is coming up again because it's a geometry-based question. Some of you have had geometry, some of you have not. In this problem, it is important to know that when you have two straight lines that cross, the angles across from each other are the same measure. So these two angles in the picture that I'm drawing are the same, whereas these two angles are the same as one another. Okay, that's what's called vertical angles. The name is not as important as knowing that property. So it says we have 3 lines that intersect at point P, and angle X is 65 degrees. Well, if you look at angle X, it is comprised of this purple line and this red line. And there's another angle that also is comprised of the purple and the red, and so it also will be 65. All right, and then I read on in my question, and it says Y is 75. So this angle over here is 75 degrees. And if I look at angle Y, it has one edge that's already highlighted purple. It has another edge that I'm highlighting in green. So a green with a purple is a 75-degree angle, and so that has to be true over here as well. And then if you think about the entire picture, another thing that I hope that you know, and if you don't, you can learn it now, is that when I go all the way around in a full rotation, that's 360 degrees. So if you ever have gone snowboarding or skateboarding, sometimes they talk about, you know, the amount of spin or turn that someone does in a move, right? They say, oh, they did a 540 or whatever. And that's expressing how much they spin or how many degrees they turn. And so if you look at this picture, we have 65 twice and we have 75 twice. So 65 twice would be 130, and 75 twice is 150. And so that already accounts for 280 degrees. And if we subtract that from 360, we would get 80 degrees. So there's 80 degrees unaccounted for. And if you look at the two angles that are missing, this guy and this guy, they both are a red edge with a green edge. So they have to be the same because of this property I talked about at the beginning. So this must be 40 and 40 to account for that extra 80. And that was the question. What is the value of Z? 40. So that one is pretty involved in terms of just sorting out everything that you're given. Okay, question 3 and 4, I'm going to just show. This one I was a little surprised about. All it's saying here is that if you take each of these points on the scatter plot and you move them each up 3 units. I said I wasn't going to talk about it and I couldn't help myself. Sorry, guys. Okay, so you have a new scatter plot that's up here. Then your line of best fit, instead of being here, is going to move up here also. So your y-intercept is going to go up. That's all. I guess I talked about number 4. Oops. Okay, question 5. I think maybe was a reading issue because I think you guys know the math of this. So here we have 2 lines. We have the green line L and we have the blue line K. And they're saying those 2 represent a system of equations. We talked about this earlier this year. And it's asking how many solutions the system has. Well, a solution to a system is where the graphs of the equations intersect. And there's just one point of intersection. So that's my answer. Okay, let's flip through a few more. Remember, you can pause at any point if you want to take a look at an answer. Remember that you can contact your teacher if you have a question about any of these that I'm just flipping past. This is a line of best fit kind of problem. Okay, so you could think about putting that line of best fit in. Think about rise over run. Make sure you're watching your units. Okay, question 10 we do need to look at. Okay, so in question 10, they talk about function f. Function f is given to us in factored form, which is very, very helpful. They could have made this question harder by having it not be factored for you already. It asked which of the following is not an x-intercept. Well, x-intercepts occur when y equals 0, and the y here is in function form, so it's f of x. So I want that to be 0. And I know that if I have any things that are multiplied together, just something in that box, something in that box. If I have 2 things multiplied together, let's say, and my answer is 0, one of these things has to be 0 because I can't multiply 2 positives and get 0. I can't multiply 2 negatives and get 0. I can't take a positive times a negative and get 0. The only way to get an answer of 0 in a multiplication problem is if one of the things I'm multiplying is in fact 0. So this is a multiplication problem. There's multiplication happening here and here. So one of these 3 things has to be 0. Either x plus 4 is 0, x minus 1 could be 0, or 2x minus 3 could be 0. If the first equation is true, then x is negative 4. This equation has a solution of x equals 1. And this equation has a solution of 3 over 2. You'd add the 3 and you divide by 2. So if you look at your answer choices, here's this one, here's this one, and here's this one. And they asked for which one was not. That's that guy. That one is not. I think that might have been a careless error situation. Okay, question 11, STEM, gets used by a couple of different questions. It's about the 2 different kinds of catfish. And this is one that we're going to talk about. Okay, so they mentioned that there's a channel catfish, and that is represented in the table. And they represented there's a flathead catfish, and that one you don't have a table for, but you have an equation. And what they're asking you to do is to look at the one that you have the table for, this guy, and try to come up with an equation. So if you take a look, it did say that the function was linear. Linear just means the function is a line. So these are 4 points on a line. They want me to find the line. Well, what I would do, because I just don't want to have to deal with the decimals, and this is personal choice, I would choose to use these 2 points. You don't have to do that. This is just one option. And I would find the slope based on those 2 points. So slope is the change in the output variable, or the y, over the change in the input variable, or the x. And so I know that that slope is 5 over 2, which is 2.5. Now, because this is multiple choice, right now I would cancel out those 2 as options. Then I would look at the other 2 options, and I'd say, okay, well, is my y-intercept going to be 6 or 8.5? 8.5 is in the table, but that is an ordered pair 1, 8.5. And I know that my y-intercept should have 0 as the x and then something else as the y. So it can't possibly be D. It has to be C. And another reason you could think of it as, and know that you were right, you know that the y-intercept has to be 6, is because this said, the slope was saying the fish grows 2.5 inches for every year that passes. So if after 1 year the fish is 8.5 inches long, then at birth it must have been 6 inches long. Go back 1 in the table to year 0 and go back 2.5 inches, and you're at the 0.06. All right, the next one we're going to talk about, this question sum is kind of a lot because you have to look at a couple different things together, but it's a question stem that got used for multiple questions, okay, and that's very common on standardized tests. If they give you something that has a lot going on, they might use that stem for different questions. Now, this particular first one that uses the table and the stacked bar graph just is asking us about range. Okay, and in statistics, the range is the maximum value minus the minimum. So that is one place where I thought, I bet maybe some of you didn't know that as a definition. If you do know that, this question is not that bad. Okay, so this is all this data about contact lens fitting. And so it was asking for the range in the average ages of the patients. The second graph has nothing to do with the age. The only place I see age in the problem is in this table, in this back column. And since I'm looking for range, I want to take the highest minus the lowest. So the highest number is like a tie by New Zealand and Sweden. Okay, so 36.5. And the lowest number was Taiwan. So in order to do this question, it's just actually a subtraction question once you know the definition. If I subtract those two, I should get my answer of 9.7. Okay, the second question that utilized those same graphs is a little more involved. So if you do need to read it again, you should pause the video and read it. I'm not going to read it to you. But over here we have how many total contact lens fittings there were by country. And then if you take that total number and you go over here, this is the breakdown of within each country, how many people were fitted for contact lens for the first time, that's in the gray, versus how many people already had been fitted for contact lenses in the past, and they were just double checking that their shape of their eye hadn't changed, that they still could use the same kind of contacts. Okay, so refittings, like, former contact lens users who were continuing on using contact lenses, that's in the black, okay, and then the new was the gray. So the question down here, this time is not about the age at all. It says, of the following, which best approximates the number of patients who received refittings in New Zealand? So I'm going to look here at New Zealand and say, okay, they had 721 contact lens appointments. And if I look back over here to the graph, New Zealand is right here. So I am trying to figure out how many people had refittings. So the refitting part is the darker part of the bar, and that's a little hard to read because it doesn't start from 0. It goes from here to here. So instead of reading that, I would choose to read the gray part and say, okay, well, that looks like the cutoff between those two colors is around 38%. So maybe this bottom part of the bar is about 38%, which would mean the top part of the bar is like 62%. So 62% of the people were having a contact lens fitting for the very first time. And on my calculator, I just did 62% of 721, and I got 447.02. So that looks like it's closest to this. Okay, and even if you had estimated these values slightly differently, right, it's not obvious that that's 38%, maybe you said 37 or 36, there's still going to be, there's enough space between the 4 answer choices that you have that it still should be clear which one is the closest. Okay, question 15 is another one that we should look at. I have a feeling that maybe you were kind of freaked out about the margin of error. That's a very specific stats term. But when I teach this in stats, I talk about how you do this in your science labs sometimes where you're figuring out how far off your estimates might be or your measurements might be. And that's basically all this question is asking about. So they have some data and they said, okay, the average amount of, or average length of a hike that people took was 4.5 miles. But they think that they might be off by about, a half a mile. So if I went a half a mile longer, that would be 5 miles. And if I went a half a mile less, that would be 4 miles, right? 4.5 plus a half is how I got this. And then 4.5 minus a half is how I got that. Okay, so your margin of error is a number that you add or subtract. Sometimes you'll see this, like if you are reading stuff about an election, they'll say plus or minus 3 percentage points or something like that, right? We think this candidate is captured, 52% of the vote plus or minus 3%. And so you'd add the 3% and you subtract the 3%. So that's what you're doing here. You're adding the half mile and you're subtracting the half mile. And so that's how I came up with answer D. It's possible or plausible, reasonable to say that the average distance the people hiked was between 4 and 5 miles. All right, I'll just show the answer on this one. Actually, for the next several, I'm just going to show some answers. This is one of those where you have to kind of muscle through the reading, but then there's many questions about it. Remember that if you want to talk to your teacher about any of these, you are absolutely welcome to contact your teacher. This is kind of like the most recent unit that we did, exponentials. This one uses some geometry. So people who've had geometry, I hope you got that one. And people who haven't had geometry, I forgive you. Okay, we're going to talk about question 25. Okay, the irony of this question is just right all over the place. It's talking about space around people, which made me chuckle. Okay, so basically they want you to find the area of the gray region. Okay, so they talk about how you have like intimate space and then personal space and then social space and then public space. And these are rings around the person. The person is the dot at the center of the diagram. And they mentioned that this inner circle, I don't even know if I can write that small, so I'm going to draw myself my own picture. Okay, they said that inner circle, this part here, has a radius, and a radius is from the center out to the edge, has a radius of 1 foot. And they say that circle around it has a radius of 4 feet. Okay, I am definitely not going to be drawing this to scale because I did not think ahead. Oh my gosh, that's maybe the worst circle I've ever drawn, and I've drawn some doozies. So, woo! Okay, so that's a 4-foot radius. And then they say your social space around that, so this, what did it say, has a radius of 12 feet. All of these are measured from the center. And they want us to find out how much space is in this part that I'm coloring in green. Okay, so basically you want to find the area of the circle that I've outlined in blue and subtract this part. And it doesn't really matter, like this part is irrelevant, as is the part they mentioned after that, right? It's just extra information that we don't need to solve for math. Okay, so we're finding the area of the circle with radius 12. We're subtracting the area of the circle with radius 4. So area of a circle is pi times the radius squared. So this would be 144 pi for the blue circle. And 4 times 4 is 16, so that's 16 pi for the red circle. And if you take 144 and subtract 16, you're left with 128, and the pi just comes along. It's like having 144x minus 16x, and you have 128x, right? If that were an x, pi works kind of like that, okay? In terms of combining like terms. All right. Question 26, I'll just show the answer on that one. Question 27. I think this is a question where you totally can do this, you guys. I think it's a matter of staying calm and not freaking out about the fact that you just read the word infinity or infinitely. Okay. Sometimes if you just keep writing, all of a sudden it's like, oh wait, I do know the answer to that. Okay, so what I just did was I distributed this -4. Okay, I'm not really sure where the question's going yet. I'm just going to play around. All right, I see that there's 2 terms with an x, but this term doesn't have an x. So I'm going to move that 12 on the left side away by adding 12 to both sides. So now I have ax minus 8x equals 0. This part canceled out, made it 0. Okay? And so they want to know what will make us have infinitely many solutions. I think this is easier to understand actually with factoring. If on the left side of the equation you say there's a common factor of x, say, all right, well, what's going to make this have infinitely many solutions? Infinitely many solutions happens when you have something like 7 equals 7, because that's always true. So I want this equation to say something like that. I want it to say, in particular, since this side is 0, I want it to say 0 equals 0. Well, what should a equal if my next step is going to say 0 equals 0? It should equal 8, right? Because then I'd have an 8 right here. 8 minus 8 is 0, and 0 times x is 0. I get something that is an always true statement. That means it doesn't matter what x is. Everything, every value of x makes that equation true. Okay, I was really proud to see that you guys got this one right most of the time. Most of you got this one right, I should say, because that's from our most recent unit. This one, I understand why you didn't get right, because this is from our next unit. So, yeah, if you'd gotten that one right, I'd be like, wow, impressive, you should teach. Okay, so this is what's called a rational equation. And you can see the reason it's called rational is because it has ratios in it, or fractions. So I can see on the right side that I have a denominator of x minus 2 and x plus 5. I'm going to try to have all of my fractions have that denominator. So right now I am writing out the equation that I was given with some spaces in there so I can kind of write some other stuff. Okay, and in order to get that denominator that's over here on the right, my first fraction is missing x plus 5. So I'm multiplying by x plus 5 over x plus 5. That's legal. That's like multiplying by 1. You can multiply by 1. That doesn't change the value. Over here, I'm going to multiply by x minus 2. I'm trying to get that denominator that I have over here. And if I multiply by something that's equal to 1, that's legal. Now, if you take a look at what I have, now all of the denominators match, right? If I'm adding fractions, I would just keep the same denominator. So the denominators match, so it must be true that the numerators match. That's what equals means. So I must have 2 times the quantity x plus 5 plus 3 times the quantity x minus 2, and that must give me r times x plus t. If I do a little bit of distributing, I have this. And if I combine like terms, have this. Now, if you look here, this is x. R is the coefficient on x. So R must be 5. And T doesn't have an x with it. Whoops. Sorry. Yeah, so T doesn't have an x with it. So T must be this 5 over here. Sorry, I'm having all these technical difficulties with the bottom of this slide. Okay, so T equals 4. And the question was, what is R times T? R times T is 5 times 4, which is 20. All right, and then our last one that we're going to take a look at is this guy. And this is, I don't know, this is just kind of a problem where you need to be a little clever. So they say this is true. A isn't 0, but it is some specific number. They want to know what's equal to x plus 1. Over here on the left, maybe I've just been teaching algebra a long time, but that cried out, factor me. That's what I heard, factor me. I factored out the A, that was the common factor. And then look at this, it wanted x plus 1. X plus 1's right there. So to get A on this side, it's connected with a multiplication, so I divide. Right, so if you wanted to show work there, you'd show it like this. The A's cancel. So x plus 1 is the same as 3 over A. Thank you so much. I know this is a little long to listen through, but I thank you, and hopefully your SAT score and other standardized test scores thank you too. Bye.